Okay, guys, and now question 12, 2017, paper one. Again, it's a function. It's the last function one that I'll be doing with you for the moment anyway. Coordinate diagram below shows the graph of the function y equals fx. So there's just our function. It's a quadratic, smiley face, remember that? So it's a positive quadratic. On the same axis and scales, draw the graph of the line x plus 3 for minus x between minus 3 and 5. Okay. So again, like I always say, before you do a graph, please, do a table. Input, output table, and we'll get our couples from this, and that's how we'll draw a graph. Okay. Doesn't have to be perfect or work of art, but it is better if we use a ruler. Inputs will go there. We'll have our function then we'll have our output, and then our couples at the end there. Okay. So inputs. Okay, our x values. What is this function again? X plus 3. X plus 3 is the function. In other words, add 3 to the input. It's very simple. Output is y, then we'll get our couples. Okay, so our domain then, that's our domain. That's our x values between minus 3 all the way to 5, okay? So 1, 2, 3, 4, 5, run out of space there a bit. Truth is, because this is a linear function, there's no bins, or only 2 of these points would do. You'd actually get away with that, and you could still draw an accurate graph. I'm just going to put in all the points, but you could do it as I said there. So replacing x with minus 3, then minus 2, then minus 1, and so on. Okay. Now, let's start with minus 3, the first one there. So minus 3 plus 3 is 0. Minus 2 plus 3 is 1. Minus 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. You can see now the y, where y is, it's gone up in ones. There's a pattern here. It's a linear pattern, so it's very easy to note it. 6. 4 plus 3, 7. 5 plus 3, 8. Couples. We have minus 3, 0. Minus 2, 1. These are the input and output. So minus 1, 2. That's where I'm getting these from. Minus 1, 2. As you can see, guys, every year one of these comes up. There's no excuse for not being able to do a graph in an input-output table and then graphing. Okay? Get practicing it. Get stuck in it. That's fine. Try and figure it out. If you can't figure it out, just get on to me and I will help you. Okay. Now, we have to put these points up here on our graph. First one is minus 3, 0. Minus 3, 0. Next one, minus 2, 1. Next one, minus 1, 2, and so on. Get a ruler, line up the first point and the last point, and hopefully they'll all be on that line then, okay? And there we have it. That is the function that they asked us to do. The function was called gx. So gx, so let's call this gx. Just label it. gx. Done. Okay, next. Use the graph to write down the points of intersection of fx and gx. So point of intersection just means where these two graphs intersect, kind of cross over each other, there and up there. So the first one is minus 1, 2. And the second one is in the top corner up there, 5, 8. Okay, next one. Another function, kx is x squared minus 2x, so it's another minus 1, another quadratic. Work out the values of k3. So kx is equals to x squared minus 2x minus 1. Here they're looking for k3. In other words, replace x with 3. You can use a calculator to work this out. Okay, just pop that all into a calculator to give you the answer. I'm just going to do it the old-fashioned way. Do it bit by bit. 9 minus 6, so that's 3. And 3 minus 1, 2. Okay. Next bit. Now they want us to draw this graph, okay? Draw the graph of the function. I'm going to stop the video here because the video file will get too long. So what I'll do is I'll put it in a separate video.